All right, this will be a quick one. We're going to do a lesson going over the definition of derivative one more time. We did problems like this when we first learned about derivatives. So now that we know some derivative rules, we are not going to go through that whole process where we like multiply this all out and cancel stuff until we are able to plug in zero. Okay, we can certainly do that, but that is not what these are intended to be. These are intended to recognize that it's in the form of the definition of derivative. All right, these are most likely how the questions will be asked on the AP exam. Okay, they're going to give you a limit that looks like this. You need to recognize it right away. Just say, oh, I know that. That's the definition of derivative. Okay, so you should be able to identify f of x because it's right there in the definition. It's minus f of x. So whatever's after that minus sign, that should be your function. Okay, so in this, we are going to identify this as f of x is equal to 2x cubed. All right, and we know that this is equal to the derivative of that function of 2x cubed. Okay, which means we can just use the derivative rule. We know our derivative rules. We multiply by the exponent, 6x, and then we subtract 1 from the exponent is 6x squared. All right, that's all you have to do on these. You recognize what form it's in, you identify the function, and then you apply the derivative rules that we've learned. Okay, let's try the next one. So we should recognize this as the derivative of, and then our function is right there, cosine of 5x. We apply the derivative rules that we learned. Derivative of cosine is negative sine of 5x. And then don't forget your chain rule, multiply by 5. Okay, I would rearrange that just so it looks a little nicer. Negative 5 sine of 5x. Okay, give the third one a try on your own, and then unpause the video and see how you did. Okay, this is a little trickier because first of all, they plugged in a number for x. So x is equal to pi over 6 right here. Okay, so what this is in this form right here. The limit as h approaches 0 of f of a plus h minus f of a all over h. Okay, where a is a constant. Okay, so it's a little tougher because if all you do is look after the minus sign, you're just like, oh, the function's 1/2. Am I supposed to do the derivative of 1/2, which is equal to 0? No, that's wrong. Okay, so you have to be able to figure out what the function is another way on this one. Okay, and so if you look back at the original problem, that's going to give you, not the original problem, I should say, you look at the first term, that should give you a clue. There's a sign there, sign of something. Okay, and so if this was sine of a, right here, this would be sine of pi over 6 right there. And that is 1/2. Sine of pi over 6 is 1/2. That's where the 1/2 comes from. So this is sine of a plus h minus sine of a. So they are looking for the derivative of sine of x. But then we have to evaluate this at x equals pi over 6. So this is a derivative at a point rather than a derivative function like the other ones. All right, so derivative of sine we know is equal to cosine of x. We're going to evaluate that at x equals pi over 6. So this is cosine of pi over 6, which we know is equal to the square root of 3 over 2. All right, hope you enjoyed that quick one. See you on the next assignment.